Hi everyone. In this video we're going to talk about Chapter 5C, which deals with statistical tables and graphs and how you display all of that data that you got from your study. So there's two different types of data. One is called qualitative data and the other is quantitative data. Qualitative data is data that describes different categories of data, and quantitative represents numbers. So classify each of the following types of data as either qualitative or quantitative. And the first one says brand names of shoes in a consumer survey. Brand names is qualitative. Heights of students would be numerical data, so that would be quantitative. And then audience ratings in a film on a scale of 1 to 5, where 5 means excellent. This one's a little tricky. This one is actually qualitative. Just because you assign numbers to something doesn't make it numerical information. The 5 means excellent, which is a category. Okay, so from there, there's something called a frequency table. The frequency table normally just has two columns. It's got whatever type of data you have and the number of times it occurs. So the categories are always on the left, and then the frequency is the number of times that the value comes up. A grouped frequency table is usually used for quantitative data, and the data is grouped together in something called class intervals, which are also referred to as bins. So the interval here is 0 through 9, the second interval is 10 through 19, and they're all displayed in groups. The lower class limit for a grouped frequency table is the leftmost number for each class. So all of these over here on the left would all be considered lower class limits. So if I asked you for the lower class limit of class 3, here's 1, 2, 3. There's your third class right here. The lower class limit would be 20. The lower class limit for class 1 is 0. So I'll specify which class the lower class limit is the one on the left. The upper class limit is the opposite. The upper class limit is the one on the right. So all of these would be upper class limits for this table. So if I wanted the upper class limit for class 2, that would be the 19, for example. And then last, the class width is the difference between any two consecutive lower class limits. So difference means subtract, consecutive means one after another, lower means left. So if you subtract any two consecutive lower class limits here, you should get the same class width. For example, 10 minus 0 is 10, 20 minus 10 is 10, 30 minus 20 is 10, or 60 minus 50 is still 10. They're all 10. They should all be the same, making sure that your class intervals are equally spread out. Then from there, there's something called the relative frequency of a category, which is the fraction that the data values fall up into that category. So how often, what's the frequency in a particular category divided by the total frequency? The cumulative frequency of a category is the number of values of that category plus everything before it. So let me give you an example. Here's the table from before. This is just the frequency table that we looked at a minute ago. 2 people in this survey have a high school diploma, 7 have an associate's degree, 20 have a bachelor's degree, 9 have a master's degree, and so on, for a total of 54 people who were surveyed altogether. To figure out the relative frequency for each of these, you take the frequency it happened divided by the total frequency. So in the high school diploma category, it would be 2 out of the total was 54. The fraction is then divided to get decimal form and then multiplied by 100 to get percent form. Percent form is usually the part that's displayed. We don't usually put the fraction and the decimal part in here, but for an explanation standpoint, I decided to put it in here so you can see where I'm getting the 3.7 from. Then for the associate's degree, I would take the 7 and divide it by 54. And then to get it in percent form, I divided 7 by 54 and multiplied by 100. For the bachelor's degree, it's 20 over 54. I then divided those, got decimal form, and multiplied by 100 to get percent form. And I did that for each of them for the relative frequency. When you're all done, this total should add up to 1 because that's 100% of your survey. Now to come up with the cumulative frequency. The cumulative frequency is the frequency plus everything before it. So in the first row, it's just 2. 2 people are accounted for in the survey so far. But then for the second row, for the people with the associate's degree, that's 9 because this frequency plus everything before it, 7 plus 2 is a 9. For the bachelor's, it's then 29 because this frequency is the bachelor's plus everything before it. Gives me 29. So it's basically a running total. This is what the frequency looks like for everything here. The last row should be the total. That means you've accounted for this row plus everything above it, and those two should be the same. So here's another example. Consider the following 20 scores from a 100-point exam. They want us to make a frequency table including the relative and the cumulative frequency. So basically we're going to make some intervals for this data here. We're going to then tally it up, put them in their correct frequency column, then we'll come up with the relative and then the cumulative frequency from there. So I decided to break my intervals up into groups of 5. So 70 to 74, 74 to 79, 80 to 84, and so on. It doesn't necessarily have to look this way as long as your class widths are the same. So if I test this, any 2 consecutive lower class limits, when I subtract them, should be the same. So 75 minus 70 is 5, 95 minus 90 is 5. Everything is 5, which means my intervals are perfectly fine. But I could have done 70 to 79, 80 to 89, and 90 to 99 if I wanted to. I just chose to do it this way because it's a little bit more spread out. Then I tallied up the data that I had and sorted it into the bins. So there were 4 people that fell into this range of values, 7 fell into this range of values, 3 fell into this range, 3 were between 85 and 89, 2 people got 90 to 94, and 1 person got between a 95 and a 99. For a total of 20 people, there was 20 scores, so that makes sense. I probably did this right. When my total matches what I'm given, I didn't miss anybody and I didn't double count anybody, but I might not have sorted them correctly. It's just a partial check. Next, for the relative frequency, I'm going to take each frequency and put it over the total. So 4 over 20, then divided it and multiplied by 100. 7 over 20, divided it, multiplied by 100. 3 over 20, divided it, multiplied by 100, and so on. At the end, I ended up with 100%, so that checks out. And then last, for the cumulative frequency, it's the running total. So for the first row, all we have is a frequency of 4. For the second row, we have 7 plus the 4 before it. For the third row, we have a 3 plus the 7 and the 4 before it. For the next row, we have a 3 plus the 3, the 7, and the 4 before it. And so on, for a grand total of 20, which matches the total in the survey. Next, we're going to talk about a couple of different types of graphs that are used to display statistical data. The first one is a bar graph, which I'm sure you're all familiar with this already. You can have vertical bars like what's in this picture here, or you could have horizontal bars. But basically, bar graphs are used for qualitative data, and each one represents a different category. Histograms, on the other hand, even though these are bar graphs, these are used for quantitative data. These are used to display range of data, like a grouped frequency distribution, for example. Because the data is continuous, for example, this is 70 to 74, then 75 to 79 starts here. There should be no space in between your bars. That's why we use them. Later, statisticians also map the midpoints of each of these bars and put a line graph on top, and that gives them distribution information. A line graph is another type of graph that's used in statistics, but these are typically used to show change over time, which they're referred to as time series graphs, but they're types of line graphs. And then there's pie charts. Pie charts are great for displaying relative frequencies because pie charts are used to display parts of a whole. And in a relative frequency, that's usually given as percent, so you can map out a pie chart very easy with that type of data. So we're going to look at the same 20 scores from an exam that we already filled the table in from before. And we're going to make a histogram and a pie chart now out of the information that we already came up with. So this was our chart from before. To make the histogram, it looks something like this. Each class interval gets its own bar with no space in between, and you graph it up into its frequency. So 70 to 74 had a frequency of 4, 75 to 79 had a frequency of 7. These two both had 3, then 2, then 1. The frequency is always on the vertical axis, and whatever your intervals are, those always on the horizontal axis. For the pie chart, I'm just going to take the percentages that we came up with for the relative frequency and use them to come up with the slices for my pie. So 70 to 74 is this color here that represented 20%. 75 to 79 is this larger wedge right here. 80 to 84 is 15%, another 15%, then 10, and then 5, all coming from the relative frequency column. Okay, and that wraps up section 5C. It's a very short section, but now with 5A and 5C, you should now be able to complete the next homework assignment in my math lab.